If you spend $40,000 a year, you need $1 million to retire. If you spend $60,000, you need $1.5 million. If you spend $100,000, $2.5 million. That is not a slogan, that is a single division. The math comes from a paper written in October of 1994 by a financial planner named William Bengen, sitting at a personal computer in El Cajon, California, running a simulation that no one had bothered to run before. He found a number. The number was 4%, and the multiplier, 25, became the most useful piece of arithmetic in modern personal finance. Before 1994, the question of how much money you need to retire was answered the way most personal finance questions are answered, vaguely: save more, spend less, have a comfortable nest egg. The advice was correct in direction but useless in magnitude. There was no number. The structural reason the question had no answer was that retirement is not one math problem. It is two math problems chained together. The first is accumulation. How much do I have on the day I retire? The second is distribution. How do I draw it down without running out before I die? The accumulation half had been studied for centuries. Compound interest goes back to Bernoulli in 1683. The distribution half, however, had no clean answer, because distribution depends on the sequence of returns. If you retire and the market crashes the next year, your portfolio takes a permanent hit that compounding cannot undo. If the market crashes 10 years into your retirement, the same drop barely affects you. The order matters. The math is path dependent. So the question, how much do I need, needed two things to become answerable. It needed a long enough historical record to test against, and it needed a person willing to sit down and run every possible 30-year retirement scenario, one by one, on a computer. In 1994, Ibbetson's database had data going back to 1926. That dataset covered 6 decades, including the 1929 crash, the Great Depression, the Second World War, the post-war boom, the stagflation of the 70s, the Volcker shock, the 80s bull market. Almost every kind of regime a 30-year retirement could possibly land in. And William Bengen, an MIT-trained aerospace engineer who had pivoted to financial planning, had a personal computer and a methodical mind. The combination is the part that matters. Computers had been around for 2 decades. Long historical datasets had been around for longer. But the specific question, what is the largest withdrawal rate that survives the worst possible 30-year starting year, had not been asked in this form. Not because the math was hard, because it was tedious. 50 separate 30-year simulations, run for every withdrawal rate between 3% and 7% in quarter-percent increments, was the kind of work that nobody had bothered to do. Bengen bothered. Here's what Bengen did. He took a portfolio split 50-50 between U.S. large-cap stocks, the S&P 500, and intermediate-term U.S. Treasury bonds. He picked a starting year anywhere between 1926 and 1976. He set the starting portfolio at $1 million. He had the simulated retiree withdraw a fixed percentage in year 1. In year 2, he increased the dollar withdrawal by the actual CPI inflation rate of that historical year. He kept doing this for 30 simulated years, marking the portfolio with the actual market returns of those exact 30 years. If the portfolio survived to year 30 with any positive balance, the withdrawal rate was safe for that starting year. He then varied the withdrawal rate from 3% to 7% in quarter-percent increments. For each rate, he ran 50 separate 30-year simulations, one for each possible starting year between 1926 and 1976. The result, when he aggregated all 50 simulations, at withdrawal rates above about 4.15%, some starting years failed. Below 4%, every starting year survived. The worst-case starting years, 1937, 1966, 1973, all came right at the edge. They survived 4%. They did not survive 4.5%. Bengen called the resulting number the safe max. He rounded it down to 4% for safety margin and published in October of 1994 in the Journal of Financial Planning. The article was 10 pages long. The mathematical insight is then trivial. If 4% is what you can safely withdraw each year, then you need 1 divided by 0.04 25 times your annual expenses, to retire. Worth pausing on this. Most retirement planning literature before 1994 answered the how much question with a moving target, a percentage of pre-retirement income, an income replacement ratio that varied with marginal tax brackets, a vague, comfortable lifestyle reference. None of those framings could be plugged into an arithmetic equation. The brilliance of Bengen's framing was that he made the expense side the anchor. Not the income side, not a percentage of anything, just the absolute dollar amount you actually spend in a year. That number you already know, you already pay it 12 times a month, multiply it by 25. That is the destination. The math has no opinion about your career, your bracket, your social class. It only cares about your annual outflow. That division is the math the rest of this episode rests on. The 4% rule does something cognitively unusual. It takes an infinite feeling problem, when will I have enough, and converts it into a finite, computable, single-line problem. The brain treats future events without numbers differently from future events with numbers. A study by Daniel Kahneman, cited in EP4, showed that the brain registers magnitudes by vividness and not by quantity. Without the multiplier, retirement is a vague mountain. With the multiplier, it is a specific mile marker on a road. There is a second cognitive shift. Once retirement is a single number, the question of when can I get there becomes a function of how much you save per year. Not how much you earn, how much you save. The savings rate is the only lever. In 2012, an anonymous engineer named Pete Adini, writing under the pseudonym Mr. Money Mustache, published a single chart. On the y-axis, years until you can retire. On the x-axis, percent of your take-home pay you save 10%, you retire in 50 years, save 25% in 32 years, save 50% in 17, save 65 in 10 and a half, save 75 in 7. The chart is one of the most viewed pieces of personal finance content on the internet because it answers the question every working person silently asks, how long do I really have to do this? With one number derived from one division, derived from one paper from 1994. The math has been there the whole time. It just had to be written down. 4 tests of the 4% rule, drawn from American market history. Case 1. The retiree who started in 1937. They opened their portfolio just before the recession of 37, which dropped to the S&P 500 by about 38% in 12 months. Then came the Second World War, then Korea, then the Eisenhower bull market. By the end of their 30-year horizon, in 1967, the portfolio had survived but with substantial volatility. Bengen's 1994 model says, this retiree's 4% withdrawal worked. It did not feel comfortable, it worked. Case 2, the retiree who started in 1966. This is the worst case in the entire data set. The retiree retired into the late 60s bull market, then was hit by the 70s stagflation. High inflation, stagnant returns, sustained for over a decade. Inflation, as Bengen himself said in 2025, is the retiree's greatest enemy. The 4% rule held, barely. The 1966 retiree finished their 30 years in 1996 with a tiny positive balance. The math worked. The retiree probably did not sleep well. Case 3, the Trinity Study, 1998. 3 professors at Trinity University in Texas, Philip Cooley, Carl Hubbard, and Daniel Waltz, replicated Bengen's work with a wider testbed. 5 different portfolio mixes, withdrawal rates from 3% to 12%, horizons from 15 to 30 years. Their finding, published in February 1998, a 4% withdrawal from a 50 to 75% stock portfolio sustained a 30-year retirement in 95 to 100% of historical scenarios. Independent replication. Same conclusion. Case 4. The Wade-Pfau Low-Yield Critique, 2013. Pfau, an economist at the American College of Financial Services, ran the same simulation under the assumption that future bond yields would be much lower than the historical record, specifically the negative real return TIPS yields of 2013. Under that assumption, the safe rate dropped from 4% to 2.5%. The rule is not universal. It is calibrated to a specific historical era. and the era can change. 4 cases, 4 data sources. The 4% rule survives in every American historical scenario, but the exact number, 4% versus 3.3% versus 4.7%, depends on the era. The structural insight is robust. The exact percentage is calibrated. 4 cases. 1 conclusion. Today's episode is sponsored. The sponsor, a private community for people who think about retirement in spreadsheet terms, not vibes. Inside, we work through the toolkit, portfolio theory, applied mathematics, and the retirement planning frameworks that make a vague goal a concrete number. If this episode hit home, the portfolio theory and applied math tracks inside go a layer deeper. Find the link below, right under the video. Now, back to the multiplier. The structural lesson from the 4% rule is not the 4%. The structural lesson is the existence of the multiplier itself. Before 1994, if you asked, how much money do I need to retire, you got a feeling, not a number. After 1994, you get one division. Whatever the exact safe withdrawal rate is, 3%, 4%, 4.7%, 2.5% in a low-yield environment, the form of the answer is unchanged. Annual expenses divided by safe rate equals retirement portfolio. If the safe rate is 4%, you need 25 times your expenses. If it's 3.3%, you need 30 times. If it's 4.7%, Bengen's 2024 revision, 21 times. If it's 2.5%, FAO's 2013 low-yield estimate, 40 times. The multiplier is the gift. The retiree who internalizes the form of the rule and who has a savings rate that gets them to some version of the multiplier has done the actual work. They have converted a fearful, indefinite life goal into a known finite math problem with a slider. There is a second insight worth stating out loud. The 4% rule does not say retire the moment you hit 25 times your expenses. It says if you retire then, the historical math gives you a high probability of not running out for 30 years. Probability, not certainty. The rule is a sufficient condition under historical conditions. It is not a sufficient condition under all possible futures. A more conservative retiree uses 30 times. A more aggressive one, willing to adjust spending if the early years are bad, uses 21 times and accepts some sequence of returns risk. The math is the floor. The choice is the ceiling. The math has been done. The retiree's job is to use it. So what's the catch? The catch is that the 4% rule, like every backtest, assumes the future will rhyme with the past. The historical period it was tested against, 1926 to 1995 in the United States, was an unusually generous era for stock and bond portfolios. American equities returned about 6.5% real per year. Treasury bonds, after inflation, returned about 2%. That equity premium of roughly 4.5 percentage points over inflation-adjusted bonds is what makes the 4% rule work. If future equity premia are lower because of low yields, lower growth, demographic headwinds, or any other reason, the safe rate is lower. FAO's 2013 number, 2.5% in a sustained negative real bond regime, is the worst-case modern estimate. Bengen's 2024 number, 4.7%, with broader diversification and updated data, is the optimistic one. The honest answer to how much do I need is therefore not a single number, but a range. 21 times annual expenses if you trust the optimistic calibration. 40 times if you trust the pessimistic one. 25 times, Bengen's original, if you want the canonical answer that has worked for 30 years and is the bedrock of the FIRE movement. The math is given. The choice of multiplier is yours. This is the 5th episode in a single mathematical arc. EP3 built compound growth, money up. EP4 mirrored it, inflation, money down. EP5 looked at variance, the shape of distributions when math compounds against you. EP6 examined the limit case, the lottery, where negative expected value is the entire product. And EP7, this one, synthesizes all 4. The 4% rule uses compound growth, inflation adjustment, the variance of historical returns, and the explicit acknowledgement that you cannot get there by chance, only by saving. Compound, decay, variance, zero, multiplier, 5 concepts, 1 arithmetic. The retirement question has been answered for 30 years. The only thing missing is doing it. Next episode, we will look at the engine that makes the 4% rule possible. The equity premium itself. Why stocks beat bonds over 30-year horizons. And what could break that pattern? Until then, do the division. The number is there.